Okay, when we went to lunch, we were writing down notes about the side-side-side congruence postulate. And what we're doing is trying to see, are there ways to get triangles congruent that don't take all 6 parts? And we were thinking about this one before lunch. I said I had pictures to put tick marks on, so mark your picture. Okay, here's one pair of sides congruent. Okay. Then there's a second.
What class are we supposed to
All right, now we're in 3rd period, and then we'll go to 2nd. Okay, 1 pair of sides congruent, 2 pair of sides congruent, 3. If you did not draw a picture on your side, draw that one. Okay. Draw the sides on there. Just sit carefully. Okay. All right. Anyone still need to finish up those notes?
Yeah, I do.
Okay. All right, so on the board, I'm going to summarize congruent triangles. Okay. Okay, congruent triangles, side, congruence postulate. I'm going to draw what they look like because we're going to have 4 different methods today, and you need to pick out which one they are. Jacob, put your iPad away. And anyone else that might have it out?
Yeah, anybody.
Okay, there's a side. All right, let's go on. So I want you to look at these and decide, are the triangles congruent? So we have side BC is congruent to side TS, side AB is congruent to TR, and AC congruent to RS.
We have to start
So-
doing theorems now, like, not theorems, proofs now, don't we?
This is the chapter we will do something. Okay, no, it's not that bad. Okay, next one. Are these 2 triangles congruent? We're doing the thinking required in a proof. All we'll have to do next week is write it down. So I'm trying to get you to think step by step. So think with me
It's
here.
not as easy as
Okay,
it is.
are the triangles congruent?
Yeah.
No, they're not.
Okay, now this one is a little bit harder picture because the triangles are hooked together. So something you need to do is draw the triangles separately as we go through these today, if they're ever hooked together. Okay, this triangle would be ABC. Have a seat. CDB. Okay, now as far as markings that are over here, AC has 1 tick mark in the other triangle. BD has that same tick mark. CD has 2, AB has 2. Now that's all that I have marked. Now once you run out of things that are given, you need to do some thinking on your own. And this is the part that I can't always do for you. So is there something else we know about those triangles?
What it looks like since they're linked together, they both have to be equal.
Yeah, this segment, that CB, is the same length no matter which triangle you're looking at. So this CB length is the same in both triangles. That will be supported by a reflexive property. If you recall, segment CB congruent to segment CB. That's what a reflexive property statement looked like. That's why there were some properties in your review yesterday. So once we have the 2 triangles drawn separately, notice it is what we're working on right now. Side, all 3 sides in both triangles. Now we will come up with the congruent triangle statement. Let's practice it on this one. If I call this triangle ABC, what order would I list the other ones so that they match right? Okay, take a look. Think. A, B, C is the 2 mark side, then the 3 mark side. So what order does the other one go? D, C, B. D, C, B. The 2 mark side, the 3 mark side, and then back. So we'll be writing the congruent statement, and we'll say it's because of side, congruence postulate. That's where we're headed. All right, another picture. Are the triangles here congruent? Okay, I want to see you draw the 2 triangles separately on your paper or marker board. Draw the 2 triangles separate and put the points on them. What points? M, R, T, S. Draw them separately. Do they have to look exactly like they are up here? No, but the closer you get them to look the same, the easier it will be to know what you're doing. Okay, so tick marks that are in the picture, given things. Segment SR, congruent to segment RT or ST. Mark those in your separate pictures. SR and ST congruent. That's all that's marked on the pictures. Now we have to think. There was something given here. What's it mean if M is a midpoint of segment RT? Does that make two segments congruent or two angles congruent if there's a midpoint? Two segments congruent. So let's look at the picture. If M is the midpoint, then segment MR is going to be the same length as segment MT because we know what the definition is of a midpoint. So on our separate pictures, RM and R and MT can be marked. I ran out of given things. What else can you come up with?
The MS.
Okay, Jacob's got that hooked together side again, right? The MS was the same one. Do you remember what I said the reason would be? Why MS in this triangle is congruent to MS in the other triangle?
Well, what if they have the same point?
It was a property. Segment MS congruent to segment MS? No, that's why the triangles are congruent. Reflexive property is what we would use on that. Okay, but our two triangles, are they congruent?
Yeah.
Yes, and so far our only method is side, 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 and that's the one that we have.
So,
Questions?
if we're supposed to be finding a way to do this faster, are we just doing it the same way?
Well, this is faster because yesterday we had to come up with all matching sides and all angles. So notice we're not even talking about the angles here. So we're skipping three things. So that is half of what yesterday was. All right. Another method is side angle side. Side angle side congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two angles are congruent. But we'll need to talk about what included side means, or included angle, I guess it is here. But this one is side angle side. So we need two pair of sides and a certain pair of angles congruent. The angles have to be included between the sides. In other words, the angle that's made up of the two sides that we mark congruent, it has to be between them. So we'll take a look at that in our pictures. Two sides and the angle between them. So up here, we've got two sides. And then the angle that's included between them, the angle that connects those two congruent sides. That would be the included angle. I think there might be some questions on your homework, just is this an included angle or not an included angle? What you need to look at is what two segments are they talking about? And is the angle basically formed by those two sides or not? Is it between them or is it not between them? If it is not included between them, this relationship does not work. It doesn't fit right. So the difference between the first one and this one is you don't need all three sides. If you have just two sides and then the correct angle, you can get triangles congruent. While some of you are finishing notes, I'm going to sketch a little bit up here. If I made a 4-inch segment, let's think about it twice, I guess, and then set an angle. Let's say this has to be a 30-degree angle. And then the other side that I made slanted up, let's say that has to be 3 inches long. So we'll cut it back and we'll say that's 3 inches. This was 4 inches. When I go to finish the triangle, the only way I can finish this to get the triangles would be to connect the ends of these two segments. I can't go closer, otherwise my lengths aren't the same. I can't go further out, it gets too long. I can't squish it down because in this situation I can't change that angle. I'm trying to show you side angle side will always make the same triangle. I don't know if I can even look the same or not. That's not, yeah. to just explain it rather than have you get out your compass and straight edge and try it, because that doesn't always work real well. But the idea is, it has to be the angle that is between the two sides. And let me show you one that it would not be. Okay, if I had these two sides as my congruent, and the angle over here, notice that this is not side angle side, because the angle is not made up of the two side lengths. Am I making that understandable? This angle is not between, so I'll say not an included angle. It's not between the two sides. The included angle is how the picture shows up.
So we put NIA,
Not included angle, actually, you'll just say they're not congruent triangles, because it's not the included angle, I guess you could say that. Okay, let's see if we can pick out, now we have two things that are possible. Could be that it's side, 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 could be side angle side, or not congruent. So here's a picture to look at. Are these two triangles congruent? Do we have all three sides matching with all three of the other triangles? We have all three sides marked? Side BC, does it say that's the same length as UT? No, is it like reflexive that we were getting on some pictures?
Yeah.
They're hooked together and that's the same? No, they're not hooked together. That's not the same one. I do not have anything that would support segment BC and UT being congruent. It's not given and I don't really have a reason. So I cannot come up with all three sides congruent.
Is the side angle side?
Is it side angle side? We've got one pair of sides congruent. We have another pair of sides congruent. Is the angle that's congruent included between those two sides? Is it hooking those two together in both triangles? Yes. So this is a yes picture with side angle side congruence. Give me a thumbs up or down. Make sense out of that, Kevin? Up or down? All right, let's try another picture. These are hooked together. Draw them separately. Draw the two triangles separately. Mark them correctly. One triangle that was the top part, one triangle that's the bottom part. J, H, F, H, F, G. All right, again, label the points on there. Okay, what's congruent? JF, congruent to GF. Okay, those two sides were marked congruent. The top angle F, JFH, and the bottom GFH are the same. Okay, I know he's getting good at that reflexive. Rest of you seeing it? Okay, they're hooked together, so this side is the same in both triangles. So is that our side angle side or side side side? It's again a side angle side. We've got two sides and the angle that hooks them together. So this one would be yes. Side angle side congruence. Next picture. Are these triangles congruent? Okay, what's the first thing you should do? Draw them separately. Draw them separately and label. I just want to see Precious thing up there. Okay, now each one of them has what? Okay, each one has a 90-degree angle or just one of them? So I would say, yeah, this top one has a right angle. Looks to be the midpoint.
So line BD would be the midpoint.
Okay, you see the tick marks for A, B, and BC, A, B, and
Perpendicular
BC?
bisector.
So yeah, if you wanted to call that the midpoint, you could, yes.
And if BD are also the congruent and
That
BC,
reflects it.
which means that the whole triangle must be also a right triangle.
I guess what we need to figure out is this bottom angle, CBD, is that a right angle or not?
Yes.
Convince me.
Well, because so far with the lengths that we have, it's making it out to be a congruent triangle. Because B is the midpoint, the whole line A, B, C, it's the midpoint, and then BD is also congruent between both triangles. And it's the midpoint, which means it's half, so
Yeah.
190-degree, and one side is 90, the other side has to be 90.
That's the part that I need you to tell me why. Why is this angle 90 if that one's 90?
Because segment AB is in the perpendicular bisector of ABC.
Okay, perpendicular bisector makes a 90-degree angle. What should these two angles total? 180, okay? So if this one's 90, 180 minus 90 would make this one also 90, like a linear pair. That's what I was trying to get you to say, some of those things, to tell me why that one's 90. So yes, this is 90 also. So as you look at the pictures, are you seeing side angle side again? Okay. That was correct. Ready for, oh, there's one more. Are these triangles congruent?
Yeah.
I didn't label them, did I?
One's smaller than the other.
One looks smaller than the other, could be just bad pictures, but what do we got? We've got side AC congruent to side CE.
And
We've got BC congruent to CD.
Oh, we got a set of linear angles, really, like a linear pair, because
These two would be a linear pair.
C is making the midpoint for both lines, BD and AE, because AE, C is the midpoint, because the segment AC and CE are both congruent. And then BC and DC are both congruent, which means that they're both.
I'm agreeing with that, I haven't heard anything about angles yet. Linear pairs, I don't think linear pairs will help us completely, because linear pairs are supplemented. They add up to 180, but I need some angles that are the same in order to do this triangle part. Avery? ACD, this one, is the same as this one? Why? There's a word we need, vertical angles.
That's what I meant.
Okay. Yeah, linear pair, it wasn't what you wanted. Now, I agree with what Avery's telling me, only those are not in the triangles. I think I'd be more interested in angle ACB, this one, and angle DCE as the vertical angles. But you have the right idea. All right, so let's look at what we've got here. Notice that we had to come up with the vertical angle stuff. So now notice your triangles have two sides congruent and the angle that's between them in both triangles. So yes, these are congruent by side angle, side congruence. I'm going to have you tell me the triangles. If I call the first one triangle ACB, how does the second one go to match up? Look, DC has 2 marks, AC only has 1. You don't want those listed first to match. You would have to go from E, C, D. That would get AC to match with EC, notice the tick marks. And then CB, the 2 tick mark, goes with CD, the 2 tick mark. So you do have to switch the order there. So it would flip, it wouldn't just fold to match. All right, let's try another method. Let's go to angle, side, angle. There are 4 of these today. Side, side, side is the easiest to pick out. Then we had 2 sides in one angle. Right now we have 2 angles in one side. Angle, side angle, congruence postulate. If 2 angles So now it's two angles and an included side. Let's keep the notes down, guys. Okay. Two angles in each triangle. And the included side, so this time it's the side that's between the two angles. So the segment that hooks the two angles together is what we're looking at this time. Included side. So this side can go to this one, for example. Angle, angle, the side between them. Angle, angle, the side between them. Yeah, there are four, and then there's some that don't work. We'll probably talk
How
about.
many total postulates are there that we have to memorize?
Um,
Like 30 something?
I don't know if there's that many postulates. There's a lot of theorems.
Well, yeah, theorems, but like, yeah, these are looking at what the 30 that you have to memorize.
I mean, through the whole course, not just this chapter.
Yeah.
No, no.
Just like all of them.
I mean,
Yeah.
for the whole course of geometry, oh yeah, there's probably more than 30 even.
Yeah.
that-
and
that
they
we will
all
go
have to be
over.
out the way.
Well, things, we will have cumulative things probably showing up pretty soon for this first half. But we'll do some review things. Okay. Okay, but there are some things that you're bringing up that we've studied before, like vertical angle theorem. That's
Yeah.
one of these that we use a lot. And that's starting to get automatic. The reflexive property right now we use quite a bit. There are some, the parallel lines like alternate interior. We'll use those a little bit, not consistently a lot. Okay, do we have the notes down? Okay, let's try some more pictures. Now what's tricky about this is we need to make sure that the side is hooking the two angles together. All right, are these triangles congruent? We've got three methods now to go from. Okay, since we're getting quite a few to choose from, I want on your marker board. Give me a yes or a no, and if it's yes, tell me which of these three you think it is. Which one do you think it is? And if it's no, then you're just guessing no. And that's right. Yeah. Are the triangles congruent? Can you give me the method there, Janelle, which of these three, if you're saying yes? Okay, now on this one, is it sides or angles? Okay, is this a side or an angle, this marking? An angle. So Janelle, this is what you need to look at. This is an angle. Okay, what is this tick mark marking? That's a side, and then this one is another angle. So it's two angles and one side, not two sides and one angle. So this should have been yes, and it was an example of angle, side, angle congruent. All right, next picture. Are these triangles congruent? What do these arrows mean?
Parallel.
Parallel. Does that mean congruent? No. So actually I have nothing marked congruent here, but let's do some thinking. First thing you should do, they're hooked together. Draw them separately, okay? Draw your two triangles separately. Draw them separately. Label the corners. That's R, S, T, U, R, T. Okay, can't come up with an answer yet. Yeah, not true enough. If you're showing me side, 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 you need to tell me what sides are congruent and support it. Are there any sides that we know congruent? Do those arrows mean congruent?
Yeah, well, parallel.
No, they mean parallel.
but the same
Parallel things are not necessarily the same length. They're just slanted the same.
length. That one.
It is the same. If you look at.
Tell me what lengths are the same.
RT.
RT is the same in both triangles?
Yeah.
That's the hooked together reflexive idea. RT, RT. Okay?
RS and T.
How do you know RS is the same length? That's not what this means.
That means parallel. Boy, you don't.
There is nothing that supports those being congruent. What did we study about
Well,
parallel
I got it.
lines and transversals?
I got it.
Got an idea?
Okay. Say UR, the segment UR and TS are both parallel to each other, which means they have to have the same angle, like
The same.
Okay,
same
so-
slope.
Slope, okay, I'm with you on angles. So
They
that,
have to meet at that
what
point.
angles would be the same? Okay, I'm gonna highlight in a color.
Angle
It's
U,
angle
Here's-
RUT and then RS.
Right.
Okay, there's the green highlighted, and I'm drawing this way. So if you can ignore the plain red right now, notice this green angle and this green angle. Alternate interior angles. See the Z? So with these parallels, you can get these two congruent, which would be the angle R in this one and the angle T in that one.
I do that.
Alternate interior angle theorem.
I do that.
Is that showing up for you? If you're dying out here, you need to bring yourself back around. This is kind of the key to this whole chapter. Okay, Jaden? Really important that you pay attention here. Okay, now in blue, I'm gonna highlight this parallel and this one. And let's take a transversal, the blue. Alternate interior angles again. This angle, congruent to this one. Where are those in our triangles? R would be this angle. And then this one, UTR is in that triangle. Okay, how many remember alternate interior angles?
Yeah.
Okay? Alright, so the Z part, notice on this one, we could make the Z two different ways. So that's how we can get some angles congruent, not the length of the sides, the angles. So what do we have in our two separate triangles? It's two angles and the side that hooks them together. Okay, two angles and the side that hooks them together. So this was a yes by angle, side, angle. Congruence. Okay. Give me a thumbs up or down. How are we doing? Really? Really?
Yeah, I remember this.
Wait,
I don't-
did you get them?
All right, how are we doing over
I
here?
remember all this stuff.
I have it
Sense or
seven
not?
I've literally been sitting
I'm not asking you to tell me yes just because. I really am asking you because I need to know if I need to be saying it, drawing it a different way.
Because trust me, if you don't know, you want to know.
Yes, you want to know this. Okay, here's two hooked together. Draw them separate. And if you're using a marker board, be sure to put the cap on, they dry out very quickly. Okay, draw your two triangles and let's mark the information. They are hooked together, so maybe something about them being hooked together will help us. This one's, oops, that's A, that's D, that's B. On this one, it's D, B, and C. Okay. What can we come up with? Aaron? They're hooked together, it's the same in both, reflexive property. Okay, segment DB congruent to segment DB. Got that? What's this mean? Segment DB bisects angle ADC and angle ABC. If you bisect an angle, what's that do? Splits it in half. Does it make two angles congruent or two segments congruent? Okay, two angles congruent. So let's go one at a time. Pick out angle ADC in your first picture. ADC is the one on the left. It says that this segment cuts it in half. Cuts that angle in half. So this angle and this angle are the same.
Yay.
Okay, mark those over here. D. Okay. Well, we're not done yet, we don't have enough yet. Here's the other angle that's bisected, the one on the right-hand end. It's cut in half, so that angle and that angle are the same. So that would be the angle B there and the angle B there. Now you can take a look. Do you see angle, side angle?
Yeah.
So, yes, yes, angle, side angle, and rates. Okay. So without them drawn separately and thinking about are they segments or angles, it's kind of difficult to do. All right, we have one more for today anyway. This one is two angles and a side, but the side's in a different place than it was on the ones we were just looking at. Okay, so get your notes down about angle, angle side. You'll notice it says non-included side. It's kind of like the order that they go in, hooked together. There's a side, an angle, and a side hooked together in that order.
Because 12-year-olds didn't make the postulate.
What would they have called it if they did?
We had this desk.
The red crayon postulate.
An A, an S, and you got the rest?
Angle side.
Oh, yeah, we'll talk about that one on Monday. Why it does not work, I'll show you. Right.
They just
I'll show you why it doesn't work on Monday. For today, I don't want it to get too confusing. We will have another relationship on Monday, and we'll clarify the ones that don't work. Okay? All right, so for today, we're trying to pick out these that are correct and make sure that we say no when it's not congruent. Okay, two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second triangle. In other words, they have to match up. Here's two angles and then a side, for instance. In this one, it needs to be in the same order. It can't be the other side. It has to be in the same order with the angles and sides. Okay, now the only difference between the one we were just doing and this one is where the side is. Notice if I had put the tick mark on the bottom side, it would have been angle, side, angle. But see how it's two angles, angle, angle, then the side? That's the difference between these last two. So it's important that we get the markings in the right places in our pictures. All right, so we'll try and pick out some angle, angle, sides. The big goal for today is that you can identify each of those correctly and know the difference between an included side and angle, an included, non-included side and angle. And as I said, this is a big part of what this chapter is about. Got your pictures to go along with this theorem. Why is this one a theorem and not a postulate? That means that we can prove this one. We won't do the proof probably, but we can prove it. We actually could use the third angles theorem to help us. Postulates are accepted as proof, as true, but theorems can be proved.
So we're learning guesses, not facts.
We're learning what?
Guesses.
Oh, not really. I'd say that it's proven, no, it's demonstrated as true, maybe not proven as true. Yeah, you really have to have some ideas to start with, and then you can build on those, and that's why you had some to start with. Okay, anyone still need the notes? Okay, let's do a few examples. Okay, are these two triangles congruent? And we've got 4 different methods. Right now, we're kind of concentrating on angle, angle, side. Is this angle, angle, side? Yeah, that's exactly the pictures that I had drawn. Okay, guys, up here, please. Don't be distracting. Here's one we have to do more thinking of. What's marked?
G, K.
And IJ. That's one pair of sides. Angle K, angle J, that's one pair of angles. So what it is depends upon what other information I can come up with. What else can we come up with and support? Vertical angles. Okay, this angle is congruent to this one because of the vertical angles. So now we've got a second pair of angles. So it's either angle side angle or angle angle side because there's two angles. Is the side hooking the two angles together? No?
Yeah.
Here's the two angles. Is the side that's hooking them together the ones that are congruent? It's not. So we do have congruence. It is by what method? It's angle angle side congruence. Okay. All right, try another one. Here's our good old parallel lines. The triangles are hooked together. What do we need to do? Draw them separate and explain. Yep. Let's get them drawn separately. You be doing some thinking. What are we going to say about them?
Do some thinking.
Okay, what's marked in the diagrams? Angle B there, curve to angle C. Okay, think with me, not jabber. Shh. Okay, Mark.
Since A, B, and C are parallel, we might have the same one.
Might have doesn't work. Okay, what did we do with parallel lines in this last example a little while back? Let me flip back a few screens. What did we do with parallels here? Remember the alternate interior angles? Okay, stick with me. Some of you are dying out on the last concepts. Okay, parallel lines and transversals.
Why you on
Okay,
the line?
let me get back to Aaron. What?
Segment AD bisects.
Okay, you can't tell me it bisects because there's nothing that tells. Okay, it's the same in both. That's about all you can say. AD is the same in both triangles, reflexive property. Okay, now let's do these parallels again. Parallel, take the slant transversal, parallel. The green angles are, again, alternate interior angles that are congruent. So if I bring those to my picture, this angle is congruent to this one, alternate interior angles. So look at the separate triangles now. Two angles and a side, is the side between the angles? Included between or not? You know what I mean?
Yeah,
Yeah? So is the answer yes or no?
It's angle and line, I don't know.
Okay, this is angle, angle, side. So is that side included between the angles? Some questions on your homework will just say, is AD included between angles C and D? Is it included between? No, not included between. Okay, the reason it's angle, angle, side is the side is not included between those two angles. All right, let me see what my last examples are. Okay, so check. Okay, let me go to the board before we would do anything there. It probably is about homework time. I want to make sure you understand the included and non-included. That's not your homework. If you're thinking that's your assignment, no. Just, let's just not show that for a second. Okay, up here. Okay, this is just checking, do you understand included side and included angle? Okay, so I'm going to put some things up here. You guys are distracting me. I'm having a hard time formulating what I want to say here. I want you to figure out if this is an included angle. Okay? Is angle B included between these two segments?
No.
Included between would mean as it formed like by them. So the answer right now is no. It's not. Is angle B, Kristen? Please. Is angle B included between those two sides? Yes. This angle is included between those two sides. It's made up of those two sides. So this was yes. What was our picture when it was no? This angle, side and side like that. This one was no. It's not included. So compare those two pictures. Notice the angle is made up of those two segments. Here, the angle is not made up of those two segments, so it's not included. Okay. The reverse idea was side. Included side, then we'll do the homework. Included side, yes or no? Okay, here's the side. Let's go angle this one and this one. Is this side included between those angles?
No.
No.
No, I was, that's what
Is this side included between these angles? Yes. Now what's the difference? The pictures are different. This one I'm focusing on the side between the angles. Here it was is the angle between the sides. They're kind of opposites of each other. Okay. Let's use some time in class on the homework so that I can come around and answer some questions. Okay. We are working on page 245 and 254.
I hate chocolate.
I hate chocolate.
Okay, let's work on that so that I can answer some questions as necessary.